Integration is like the reverse of differentiation, and like differentiation there are some rules for doing it. One of the first rules you need to know is if you have a general function, y equals ax to the power n, to integrate it, what you do is you take the a, you divide it by the power plus 1, then you've got the x, and you increase the power value by 1, so it becomes n plus 1, and you also have to add a c to the end of all of this, which is known as the constant of integration. Whenever you integrate anything, you need to add this constant of integration. It represents some value of a number. You don't know what it is, but it's needed whenever you integrate. So say I have a function y equals 4x to the power 3. If I wanted to integrate this, first up what I'm going to have to do is take the 4 in front of the x and divide it by the power plus 1. So I take the 4 and divide it by 3 plus 1. Then I take the x and I increase its power by 1. So the power goes from 3 to 3 plus 1, and I have to add in this constant of integration. Never forget to do that. So 4 divided by 4 is just 1, so you don't need it. X to the power 3 plus 1 is x to the power 4 plus the constant of integration c. And that's the integral answer. What about when you have a function x to the power negative 1, which is 1 on x? Well, this is a special case. You can't use the rule we've just done. You have to use a different rule. And this rule is fairly simple. When you integrate anything to the power negative 1, your integral is the natural log of the variable plus the constant of integration. Don't forget about that. So ln is the natural log. What about when we have a function e to the power x? Well, this is very easy to integrate. The integral is just the same thing with the constant of integration added in. So the integral is e to the x plus c, our constant of integration. What about when we have more than one term in our function? Well, that's easy. You can just integrate each term separately. So if I want to integrate this, I can integrate the 6x squared term first. So I take the 6 and I divide it by the power plus 1, multiply this by x and increase the power of x by 1. So that's the first half done. Do the same, so I take 5 divided by the power plus 1, which is 4 plus 1, times x, and I increase the power from 4 to 5. So this becomes 6 divided by 3, which is 2, x to the power 3. Whoops, and I forgot to put the constant of integration there. So x to the power 3 plus 5 on 5 is just 1, which we don't have to write. So x to the power 5 plus our constant of integration c. Another type of function you might have to integrate are trigonometric functions. So say we wanted to integrate cos x. Well, the integral of cos x is easy. It's just sine x. And what am I forgetting? I've got to add the constant of integration in, c. Tiny bit trickier when the function is sine x. The integral of sine x is actually negative cos x. And what am I forgetting? I've got to remember to put in the constant of integration, which remember just represents some value. We don't know it. Now, we haven't actually been using a symbol or anything, but there is an integral symbol which is widely used, and it's the little squiggle I just drew. So to use the integral symbol, say I wanted to integrate or show that I'm integrating the function 10x to the power 4. Well, what I can do is write the integral symbol a little squiggle. And then what I write is the function 10x to the power 4, and then I have to write d followed by whatever the variable is we're integrating. So in this case it's x, so I write a d followed by x. So this is pronounced dx. And you always have to end your integral statement with a dx or a dt or whatever the variables are that you're integrating. So now, if that I've written the integral, I can go out and calculate what it is. So I take the 10, divide it by the power plus 1, 4 plus 1, multiply by x and increase the power by 1. And don't forget about my constant of integration. And I get 2, 10 divided by 5 is 2, x to the power 5 plus c. Now sometimes you have more complicated functions that you need to integrate. Say this one, which is 3x minus 4 to the power 3. Now you can't straight out integrate this. First I'm going to write the proper way of showing how I want to integrate this. So I put the integral sign, put the function there, 3x minus 4 all to the power 3, and then put dx after it. So that's the question. Now working it out, I have to use a few tricks. First of all, what I can do is use a variable. I'm going to use a u to equal what's inside the brackets. So I'm going to let u equal 3x minus 4. Now I can rewrite the integral, but instead of 3x minus 4, I'll just write u. So it becomes just the integral u cubed dx. Now I can't integrate this yet because the variable in the integral is u, but the dx at the end is with respect to x, not with respect to u. I need to have it du somehow. Now the trick here is look at your u function and see if you can differentiate it. So I'm going to go du dx, so the differentiation of u with respect to x is just going to be 3. The 3x becomes 3, the 4 just disappears. Now what I can do is put this du dx back into our integral. So what I'm going to do is write our integral as we have it here. So integral sign of u cubed dx, and I'm going to multiply this by du dx. So I'm going to put that at the end. But of course we know that du dx is equal to 3. So because we're multiplying by 3 at the end, we also need to divide by 3 somewhere else. Otherwise it won't be unchanged overall. So I'm going to divide, or put a fraction, 1/3 in front. So the 1/3 will cancel out the du dx, which we know is 3. Now the neat thing we can do now is cancel out the dx's. See how we've got a dx and we've got a dx on the denominator, and they cancel out. So I can rewrite the integral as 1/3 u cubed, and now we have du. So we have a function with respect to u, and we also have a du at the end of the integral. So now we can go ahead and work this out, just like we would a normal integral. So we take the 1/3 and we divide it by the power plus 1. So we have 1/3 and we divide this all by the power, which is 3 plus 1. We multiply this by u and we increase the power by 1, so it becomes 3 plus 1. And don't forget, we need the constant of integration, which is c. So what's a third divided by 4? Well, a third divided by 4 is a 12th, 1/12. We have the u, and we've increased the power by 1, so we have u to the power 4. And instead of u, I'm going to write what u actually equals, which is 3x minus 4. And it's to the power 3 plus 1, which is 4. And then don't forget about the constant of integration. And that's your integral answer.